Welcome to day 8 of our descriptive statistics unit. All right, for today's lesson, all you're going to need is something to write with and possibly a ruler or anything that you can draw a straight line with. Okay, for today, we are going to be taking a look at our goal, which is given two sets of data, you will be able to compare and contrast their distribution using the SOX method. All right, so today's goal, to compare and contrast two sets of data, and we're going to be using something called the SOX method. All right, so let's take a look at, well, what exactly does SOX mean? Okay, well, here we go. When you're comparing your distributions, we are going to be using what's called SOX, S-O-C-S. All right, so the first S stands for the shape. So when we're describing our distributions, we are going to be talking about, well, are they symmetric? Or are they skewed right or left? You also want to make sure that you're describing if there are any outliers. You're just going to write down what the outliers would be. Next is the center. So for the center, depending on the type of graph that we're looking at, you're going to want to write down, well, what is the mean or the median of the data set? And finally, the last S stands for the spread. So you're going to want to give the range, or if you're looking at a box plot, you can give the 5-number summary. All right, because that will also give you a very good idea about what the spread would be. All right, so let's go ahead and let's take a look at our very first, comparison of two distributions. So here we have Professor Blumzak compared the scores on the first two exams of his Calculus 1 class. He displayed the scores in the following histograms. Compare the two distributions and describe any differences you see in the shape, center, and spread of the distributions of scores for the two tests. So we take a look. Okay, Professor Blumzak very nicely put them in the form of two histograms. So we have the number of students and then test scores along the bottom. So the first thing we want to do is we want to compare the distribution. So what we're going to do is we're going to go ahead and we're going to go through the SOX method. So underneath here, I'm going to go exam 1, and I'm going to go S-O-C-S. Okay, so the first thing they want to know is, well, what is the shape of the distribution? Well, if I look at the shape, it's not symmetric. In fact, it's got a big bump on the right and a tail on the left, which means this is going to be skewed left because there is a tail on the left-hand side. Next is the outliers. Well, there's no break in my data, so I'm going to say that there are none. Next is the center. Okay, well, for the center, it's not very easy to tell where my center for this data is because it's not symmetric. So what we're going to do instead is we're going to try to find out, well, where is the median located? So to do that, I have to find, well, where's the middle score going to be located? So I'm going to go through and I'm going to take a look to see, well, how many students are in each of these bars? Well, if I take a look at the first one, this bar is over here, which is approximately 3 students. This bar is a little bit above the 5, so I'm going to say that's going to be 6 students. This is approximately, I'd say, 12 students. This bar is a little above the 35, so I'm going to say this is 36 students. And then this is right at 30, so there's 30 students in this bar. So now if I add all of those up, so 3 plus 6 plus 12 plus 36 plus 30, okay, there's 87 total students. So 87 total students. All right, which means to get to the median, I'm going to divide that in half. So to get to my halfway point, I need to be approximately 43 students in. So if I take a look here, 3, 6 is 9, plus 12, okay, that's going to get me to 21. So to get to 43, well, that's going to be in this bar right here. So that means the center, my median, is going to be between 80 and 89. Okay, so next is the spread of the data. So the spread is the range. So from the lowest point to the highest point, the spread is from 50 all the way up to 99. Okay, now that we're completed the first exam, now let's take a look at exam 2. Exam 2. Once again, we're going to go through our SOX method. Okay, so let's take a look first at the shape. Now, if I look at the shape of this distribution, it's nice and symmetrical for the most part. So we're going to write down symmetric, which means all of the data is towards the middle, and then it kind of goes outward and it gets lower as it goes out. Next, outliers. I don't see any breaks in my data, so I'm going to say there are none. So the center, remember, when your data is symmetric, the mean and the median should be right in the middle. So this right here is going to be my center. So my center is going to be between 70 and 79. And my spread is from 50 is my lowest score, and my highest score is 99. So we've now just compared the two distributions using our SOX method. So now, which exam would you like to be part of and why? So let's go through, let's analyze these comparisons. Would you rather your data be skewed left? Most of the exams are on the right. Or would you rather be symmetric, so most of the exam scores are right in the middle? All right, let's also take a look at the medians. The median for the first exam, the center was 80 to 89. Over here, the center was 70 to 79. So keep thinking, which one would you rather be part of? They have the same exact spread. All right, so in this case, I think I would have wanted to be part of exam number 1 because since they have the same spread, okay, the center is much higher in the first exam, so more people, okay, scored a higher grade in exam number 1. So here we go. So since both classes had the same spread, I would want to be in exam number 1 because the center was higher and more people scored higher since it was skewed left. Okay, so there's our very first example of describing our distributions. So let's now flip to the back and let's take a look at one more example. This time, we're going to be working with some box plots. All right, so let's take a look here. We have below are the box plots for results from Miss K's period 1 and period 5 class. So if we take a look, period 1 class, here are our exam scores, and period 5, here are the exam scores. So let's go ahead and let's compare our graphs. So once again, we're going to want to use our SOX method. So I'm going to go ahead. So for period 1, I'm going to go SOCS. So S stands for the shape. So let's take a look here. The shape of our first one, if I take a look, each one of those parts is what's approximately the same. So this would be symmetric. If I look, there's no outliers, none. Now the center, it's pretty easy to tell here. So the center, we just go to the middle line and we follow that down. So I see my center is approximately, I would say, 74. Now, for my spread, in this case, since it's a box plot, I'm going to go ahead and give my 5-number summary. So my min, my Q1, my median, my Q3, and my max. So I'm going to use my ruler to help me here and analyze that. So if I take a look here, my min, if I follow that straight down here, it looks like it's approximately, I would say, 32. My Q1, I take that number, I follow it right down. I would say that's pretty much about 50, 52. All right, I already know my median there was 74. My Q3 looks like it's about 81. And my max looks about to be 100. Okay, so now let's take a look at period 5. Again, we're going to go through our SOX method. So if I take a look at my period 5, I see there's a long tail on the left. So remember, if there's a big tail, that's going to be skewed, and it's skewed in the direction of the tail. So the tail's on the left, it's skewed left. Outliers, there are none. There's no dots or stars to designate outliers. Next is the center. So the center for this data, if I take a look, oops, it's right about there, which approximately is 81. All right, and next we go to our spread. So once again, I'm going to go through with my 5-number summary. Q3 and the max. So let's go through here and find our 5-number summary. So here, if I take a look, the minimum score is about 25. My Q1, I go way up here, carry that down. It's about, I would say, about 79. My median, it's kind of the same as the Q3 for the other one, which here we have to be 81. My Q3 here I have is 90. And my max is right up there at 100. Okay, so let's take a look here. So which class, now that we're going to compare them, which class had the higher minimum? Well, the higher minimum is definitely period number 1. But now we don't want to stop there. The minimum's not everything, it doesn't explain everything about a distribution. So we want to make sure we look at all the different data points that we just collected. Which class had a higher Q1? So here we have 52, here we have 79. So that's going to be period 5. Which class had a higher median? 74, 81. Again, that's going to be period 5. Which class had the higher Q3? Again, that's going to be period 5. Which class had the higher max? Well, it looked like both of them were at 100, so that would be neither. They were both the same. Which class had the smaller interquartile range as the middle 50% of the data? So that's the box part. So the smaller box, well, that would again be period 5. So which class would you say did better on the test? Well, I would definitely say period 5, okay, definitely had the better scores and results. Okay, so ladies and gentlemen, our goal for today was to be able to compare and contrast 2 data sets using the SOX method. And we just did that with using histograms and using box plots. All right, I'll see you all tomorrow.